to start then, we have Andrew Watson. So if you'd like to share your screen, Andrew, you'll have 2 minutes from when you start.
Sure. Okay, that working fine?
Yep, that's fine.
Great. Right, so this is going to be a quick introduction to the main recent fault. This is a right lateral strike slip fault in western Iran in the Zagros. It's seismically active, and it also tracks along the suture of the Arabian and Eurasian plates, the collision of which is sort of driving interseismic motion on this fault. So we're interested in this for two perspectives: one, the sort of seismic hazard perspective, and two, understanding sort of the distribution of deformation in Iran from continental collision. So there's been some previous work to estimate the slip on this fault, and that's come from either GNSS estimates or geological, geomorphological fieldwork estimates. There's been no previously published INSAR work, so that's where we're stepping in. We're using Sentinel-1, looking at these 4 tracks up here, and this is something we want to sort of make velocity maps, and then we're hoping to expand further to a velocity field for the Zagros in Iran. So methodology-wise, using the LIX system and LIX Basio time series, so small baseline. We're doing atmospheric corrections with GACOS. I'm also experimenting with a few other things, like trying to remove co- and post-seismic earthquake signals. So this is an attempt for getting rid of the magnitude 7.3 Sahab earthquake in 2017, and also calculating the spatial correlation of our data, and that we can then propagate through our decomposition. So we take our ascending and descending tracks, our 2 look directions, and then we decompose those to get fault parallel velocity with hopefully a decent estimate of the errors. So once we have that fault parallel velocity, we're using a 2D screw dislocation model essentially, and a Bayesian approach, the same one that Iqbal Hussain used for some of his papers, to try and estimate the slip rate on this fault. So our sort of preliminary results, this is from 2 of those frames, descending and ascending. Merge those together, we've estimated a slip rate of 3.8 plus or minus about 2 mil a year. We can't get the locking depth, it's very poorly constrained. We can set a lower bound of somewhere like 18 kilometers, which is what we fixed it to for this model. And this is consistent with the GNSS, which is good, but it isn't consistent with some of those longer term geological estimates, which is something we're looking into more. Thank you.
Brilliant. Thanks so much, Andrew. Okay, so we've now got a couple of minutes for any quick questions via Zoom. Well, I'll ask one while waiting. What's the next steps then, Andrew?
So I want to get, there's the rest of those, there's 2 more frames, and those 4 frames also have a 4-frame overlap area. So once all the time series cleared up, the earthquakes are dealt with, all of that, I want to look at that merged area, and hopefully that'll really squish the noise down. And then from there, we can expand to the rest of the Zagros, hopefully with this methodology, and look at more faults and picking out other features like groundwater and basin dynamics and things like that.
Okay, great. And there's a quick question there then from Alex Copley. Does it look like it's creeping?
I don't think so. I think there's quite a lot of noise, specifically around the fault, and there's annoyingly, because of where the fault runs, there's then basins next to that fault, and quite a few of those have agriculture and subsidence. So you end up with big areas where you can't hugely trust what you're seeing because it's probably groundwater. But at some point, I took the creep thing out of the inversion. At some point, I will try adding it back in and see what it spits out. For curiosity.
Great. Thanks so much.